इसमें देखते हैं स्ट्रिंग कॉन्स्टेंट। सो तीन कॉन्सेप्ट है, स्ट्रिंग कॉन्स्टेंट, पुली कॉन्स्टेंट, वर्क डन बाय टेंशन इज जीरो। String constraint concept says कि as length of the string is constant, so concept says कि as length of the string is constant, as length is constant, velocity is also constant, acceleration is also constant. So that is the string constraint. So this concept says कि as length of the string is constant, then velocity and acceleration along the string is equal at each and every point. As length is constant, velocity and acceleration remain same at each and every point. Velocity and acceleration remains same at each and every point. Each and every point. So question, so this moves with speed 4 meter per second. As this moves with speed 4 meter per second, so what is the velocity for m1? So m2 moves with velocity 4 meter per second. M2 moves with velocity 4 meter per second. So what is the velocity for m1? What is the velocity for m1? So what is the velocity for m1? So we have to find the velocity for m1. So we have to find the velocity for m1. So this point velocity is 4 meter per second. This velocity is also 4 meter per second. This velocity is also 4 meter per second. So speed at m1 is also 4 meter per second. Speed at m1, this is also 4 meter per second. Speed at m1 is also 4 meter per second. That is the answer. So this is m1. As this is m1, this is m2. This is m1, this is m2, and this velocity is v, and this angle is 37 degree. So m1 moves in downward direction. m1 moves in downward direction with 10 meter per second. m1 moves in downward direction with 10 meter per second. So this also, so this is v, this is 37. So if this is v, this is 37. So this is v, this is v cos 37. This is v cos 37. According to string constraint, speed is constant at each and every point. According to string constraint, speed is constant at each and every point. So v cos 37 equals to 10. So v cos 37 equals to how much? V cos 37 equals to 10. So v cos 37 equals to how much? So you have to draw a right angle. So this is the right angle concept. So as this is the right angle concept, this is 3, this is 4, this is 5. Small facing is small, large facing is also large. Small facing is small, large facing is large. So cos 37 is b by h. Cos 37 is b by h, that is 4 by 5. So cos 37 is b by h, 4 by 5, that is 10. V equals to 5 into 10 divided by 4. So 2 into 2 to 5. V equals to how much? 25 by 2 meter per second. V equals to 25 by 2 meter per second. That is the speed. Speed equals to 25 by 2 meter per second. That is the speed. So this is velocity Vb. This is velocity Vb. This is 53. Velocity Vb. This is 53. This is 37. So this is 50 meter per second. So this component, this is Vb, this is 53. So this is Vb cos 53. Vb cos 53. This is Va sin 30, Va cos 37. If this is 37, this is also 37. This is VA cos 37. So VB cos 53. VB cos 53 equals to VA cos 37. VB cos 53 equals to VA cos 37. So VB cos 53 equals to VA cos 37. So this is 50. So this is VB cos 53 equals to how much? Cos 53. This is right angle. Small facing is small. 3, 4, 53, 5. So VB cos 53 equals to B by H. 3 by 5. So VA cos 37 equals to B by H. So this is VA equals to 50. VB into 3. VA equals to 50. VB equals to 200 divided by 3 meter per second. VB equals to how much? VB equals to 200 by 3 meter per second. This is VB. VB equals to 200 by 3 meter per second. This is VB. So this is string constraint. So next is pulley constraint. String constraint. Next is pulley constraint. String constraint. Next is pulley constraint. In case of pulley constraint, so we have to find formula for the pulley constraint. So what is the formula for pulley constraint? So first we have to draw the diagram, then we will explain details about this pulley constraint. So this is the rigid support and this is the pulley. So this is M1, this is M2. So M1, M2. So this speed is V1, this speed is V2. This length is X1, this length is X2. This is X1, this is X2, and this is X0. This is X1, this is X2, this is X0. Total length of the string is constant. Previously we have studied total length of the string is constant. That's why velocity and acceleration remains constant at each and every point of the string. So in this case, length of the string is constant. So we can write as total length is constant, X1 plus X0 plus X2 equals to constant. So differentiating both the side, dx1 by dt plus dx naught divided by dt, dx2 divided by dt equals to 0. So dx by dt equals to v1 with respect to p, dx naught by dt, so this is also 0, dx2 by dt, this is v2p equals to 0, v1p equals to v1 minus vp, v2p equals to v2 minus vp equals to 0. So v1 plus v2, v1 plus v2 equals to how much? v1 plus v2 equals to twice the vp, v1 plus v2 equals to twice the vp, या फिर vp equals to how much? vp equals to v1 plus v2 by 2, vp equals to v1 plus v2 divided by 2, so that is vp, vp equals to v1 plus v2 by 2, vp equals to v1 plus v2 divided by 2, vp equals to v1 plus v2 divided by 2, so that is vp, vp equals to v1 plus v2 by 2, that is vp, vp is the speed of pulley. So let's do one example based upon this pulley constraint. So question is given, so this is a, this moves with 4 meter per second, find the velocity of a, find velocity of a, so vp equals to how much? vp equals to va plus vb divided by 2, vp equals to va plus vb divided by 2, vp equals to 4, as vp equals to 4, vp equals to 4, that equals to va, vb equals to 0 divided by 2, va equals to how much? va equals to 4 into 2, that is 8 meter per second, speed of a equals to 8 meter per second, that is speed of a, that is 8 meter per second. Speed of a is 8 meter per second. So moving to the next question. So this moves with 6 meter per second. This is A, this is B. So this is A, this is B. A moves in downward direction with 4 meter per second. So we know that Vp equals to V1 plus V2 divided by 2. So Vp equals to 6. V1 equals to how much? V1 is downward, so this is minus 4. V2, so we have to find this V2. So this is 6 meter per second. V1 is downward, so this is minus 4. V2, we don't know V2, so the sign of V2 gives the direction. So 6 into 2, 12 plus 4 equals to V2. V2 equals to 16 meter per second. V2 equals to 16 meter per second. As V2 is 16 meter per second, V2 moves in upward direction. V2 is 16 meter per second, so that moves in upward direction. V2 is 16 meter per second, that moves in upward direction. That is V2. So for V2, Vb is we have to find the speed of Vb. So V2 equals to Vb plus this is 0 plus 0 divided by 2. V2 is 16, this is Vb divided by 2. Vb equals to how much? Vb equals to 32 meter per second. So this is Vb equals to 32 meter per second. So this is Vb. This is 32 meter per second. So next is work done by tension method. So string constraint, Pulley constraint. Next is work done by tension method. 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 So work done equals to how much? Work done by tension method. Work done equals to F dot S. Work done equals to F dot S. Work done equals to F dot S. As work done is F dot S, if theta equals to 90 degree, if theta equals to 90 degree, work done equals to Fs cos 90. Work done equals to Fs cos 90. Work done is 0. Work done is 0. So work done by tension method. Work done by tension method says ki T dot x equals to 0. Then summation T dot V equals to 0. T dot V equals to 0. Summation T dot A equals to 0. T dot A equals to 0. T dot x equals to 0. T dot V equals to 0. T dot A equals to 0. So that is work done by tension method. So question. So this is t dot a equals to 0. For this a, tension is directed. For this a, tension is directed upward. Tension is directed upward. Acceleration is directed. Acceleration is also directed upward. Tension is directed upward. Tension is directed upward. Acceleration is also directed upward. Tension is directed upward. Acceleration is also directed upward. So T dot A equals to 0. So as T dot A equals to 0, T into acceleration of A, T into acceleration of A plus for B, this is tension to T is in the upward direction. Tension to T is in the upward direction. Acceleration AB is in the downward direction. To T is in upward direction. Acceleration B is in downward direction. So 2T into acceleration B, 2T into acceleration of B, as both are oppositely directed. So this is minus 2T into B equals to 0. So T into A, acceleration of A, 2T into acceleration of B, dt gets cancelled. So acceleration of A equals to how much? Acceleration of A equals to twice acceleration of B. Acceleration of A equals to twice into acceleration of B. So that is the relation between the acceleration. So that is work done by tension method. So we'll do another one question based upon this concept. So this is work done by tension method. So question is given. So this is a tension T is directed upward. So find the acceleration of B. So rule is summation of t dot a equals to 0. As t dot a equals to 0, t dot a both are oppositely directed. ta, this is cos 180 minus 1 plus 3t into 3t into a b equals to 0. t into a acceleration a, both are oppositely directed, so this is negative. 3t into acceleration of b, both are similarly directed, so this is t into acceleration of a, this is minus 1. This is 3t into acceleration of b, this is minus 1. So tt gets cancelled. Acceleration of a equals to 3 into acceleration of b. So that is the relation between the acceleration of a equals to 3 into acceleration of b. So that is the relation between acceleration.